Hello, I am Guruprasad Upadhya, HOD, Department of Mathematics, Canara Engineering College, Bantwal. In the 7th lecture in Calculus and Linear Algebra 18MAT11, Module 3, I am going to discuss beta gamma functions. Beta function. For any real numbers m and n greater than 0, that means for positive real numbers m and n, beta m comma n is integral 0 to 1 x power m minus 1 1 minus x power n minus 1 dx. We can express this beta mn in another formula also by substituting x is sin square theta, then 1 minus x becomes cos square theta. 1 minus sin square theta is cos square theta. When x is sin square theta, dx is 2 sin theta cos theta d theta. And when x is 1, sin square theta is 1 means theta is pi by 2. And when x is 0, theta is 0. Therefore, this integral becomes 0 to pi by 2 sin power 2 into m minus 1, that is 2m minus 2 into, here one more sin theta in dx. So, sin power 2m minus 1 theta cos power 2n minus 1 theta d theta into 2. Therefore, 2 times of 0 to pi by 2 sin power 2m minus 1 theta cos power 2n minus 1 theta d theta. If I replace 1 minus x by y, the formula remains same. Therefore, we can write beta mn is beta nm. Or if I substitute x is cos square theta, then also we can prove that beta mn is beta nm. So, it is commutative. Now, from these two results, to evaluate some integral of the type integral 0 to 1 x power p into 1 minus x power q dx. So, that can be evaluated directly beta p plus 1 comma q plus 1. If m minus 1 is p, then m is p plus 1. n minus 1 is q, then n is q plus 1. And hence, integral 0 to 1 x power p 1 minus x power q dx is beta p plus 1 comma q plus 1. Or the variable may be anything if the limits are same. So, you can write like this integral 0 to 1 y power p 1 minus y power q dy is also beta p plus 1 comma q plus 1. And similarly, 0 to pi by 2 sin power p theta cos power q theta d theta is half beta p plus 1 by 2 comma q plus 1 by 2, because if 2m minus 1 is p, then 2m is p plus 1, m is p plus 1 by 2, m is p plus 1 by 2, and 2n minus 1 is q means 2n is q plus 1, and hence n is q plus 1 by 2. So, remember these two formula to evaluate the integral of this type. The first one is integral 0 to 1 x power p 1 minus x power q dx. So, it may be variable, may be x or y or z or anything. If the integral is in this type, so that can be evaluated by beta functions, that is beta p plus 1 comma q plus 1. Similarly, integral 0 to pi by 2 sin power px cos power qx dx is half beta p plus 1 by 2 comma q plus 1 by 2. For the integral value of p and q, that we have the formula, reduction formula, that we discussed in the first lecture. But for the fractional value of p and q, this is useful, half beta p plus 1 by 2 comma q plus 1 by 2. Now, gamma function. For a positive real number n, gamma n is integral 0 to infinity e power minus x, x power n minus 1 dx. So, this is the definition of gamma function for positive real number n, and this is very important. This Definition is holds good for n is positive. If n is complex number, then if the real part is positive, then you can apply this rule or formula. So gamma n is integral 0 to infinity e power minus x power n minus 1 dx. Suppose x is y square, e power minus y square. Y square power 2n minus 1 means y power 2n minus 2. If x is y square, dx is 2y dy. Therefore, take 2 outside. So 2 times of 0 to infinity e power minus y square y power 2n minus 1 dy. So, or replace y by x. So, one more formula for gamma n is 2 times of 0 to infinity e power minus x square x power 2n minus 1 dx. See, we can represent the gamma n in two different integral formula. One is integral 0 to infinity e power minus x power n minus 1 dx. One more is 2 times of 0 to infinity e power minus x square x power 2n minus 1 dx. You can use any formula. Okay. Now, suppose you want the integral of the type 0 to infinity e power minus x power p dx. That can be evaluated directly using gamma function, that is gamma p plus 1, and integral 0 to infinity e power minus x square x power p dx, that is half gamma p plus 1 by 2. So remember these two results or the formula to evaluate the integral of these types. So 0 to infinity e power minus x power p dx is gamma p plus 1. Integral 0 to infinity e power minus x square x power p dx is half gamma p plus 1 by 2. So remember these two formulas to evaluate some integrals. Now the relation between, before discussing the relation between beta gamma functions, just remember this formula. This is obtained by some Fourier series concept. Gamma n into gamma 1 minus n is pi by sin n pi. Remember this formula, please note down. Gamma n into gamma 1 minus n is pi by sin n pi. Okay. Now, relation between beta gamma functions. Beta mn is gamma n by gamma n m plus n. To prove this result, use the second formula of gamma function and second formula of beta mn. Gamma m and gamma n. First define gamma n, that is 2 times of 0 to infinity e power minus x square x power 2n minus 1 dx, and represent gamma m in terms of the variable y. So 2 times of 0 to infinity e power minus y square y power 2m minus 1 dy. Take this as equation 1 and equation 2. See, 2 times of this n, here 2 times of m minus 1. Okay, here e power minus x square, here e power minus y square. Similarly, represent gamma m plus n as a variable, one more variable r. So gamma m plus n is 2 times of 0 to infinity e power minus r square r power 2 times of this m plus n, 2m plus 2n minus 1 dr. Gamma m plus n is 2 times of 0 to infinity e power minus r square r power 2 times of this number, that is 2m plus 2n minus 1 dr. So it's very easy to remember the formula. If you are able to write gamma n formula, you are able to write gamma m and gamma m plus n. And beta m comma n is 2 times of 0 to pi by 2 sine power 2m minus 1 theta into cos power 2n minus 1 theta d theta. Take this as equation 4. To prove beta m comma n is gamma n by gamma m plus n, so it is enough to show that gamma m into gamma n is beta mn into gamma m plus n. Take this gamma m plus n right side. That means equation 1 into equation 2 is equation 3 into equation 4. Now first multiply equation 1 and 2. Gamma m into gamma n. 2 into 2 4. double integral 0 to infinity e power minus x square into e power minus y square is e power minus x square plus y square y power 2m minus 1 x power 2n minus 1 dx dy. Equation 1 into equation 2 is gamma m into gamma n 4 times of 0 to infinity e power minus x square plus y square y power 2m minus 1 x power 2n minus 1 dx dy. Change this double integral into polar form. X is r cos theta, y is r sin theta, dx dy is r dr d theta, and integral 0 to infinity means first quadrant. X varies from 0 to infinity, y varies from 0 to infinity means first quadrant, and hence theta varies from 0 to pi by 2. For every theta, r varies from 0 to infinity. Therefore, gamma n into gamma n is 4 times of 0 to pi by 2. Theta varies from 0 to pi by 2. R varies from 0 to infinity. E power minus x square plus y square is nothing but r square. Y is nothing but r sin theta power 2m minus 1. X is r cos theta power 2n minus 1. Dx dy is r dr d theta. Since the limits are constant, we can separate the integral. While separating the integral, this 4 is also taken as 2 into 2. So 2 into 0 to infinity, r varies from 0 to infinity, e power minus r square, r power 2m minus 1 into r power 2n minus 1 into r power 1 dr. Therefore, it is r power 2m plus 2n minus 1. See this 2m minus 1 plus 2n minus 1 plus 1. Minus 1 plus 1 cancels, 2m plus 2n minus 1 power. And theta, so 2 into 1 more 2, 2 into 2 4. So theta varies from 0 to pi by 2, sin power 2m minus 1 theta, cos power 2n minus 1 theta d theta. Now this is nothing but, by the equation 3, this is gamma m plus and this is beta mn, and hence this is equation 3 into equation 4, and hence beta mn is gamma m into gamma n by gamma m plus n. So this is the required result. Relation between beta mn and gamma functions, beta function and gamma functions. Theorem: prove that gamma n plus 1 is n gamma n, and also for positive integer n, prove that gamma n is n minus 1 factorial. Now, gamma n formula, first formula is 0 to infinity e power minus x x power n minus 1 dx. Now n is replaced by n plus 1. So gamma n plus 1 becomes integral 0 to infinity e power minus x x power n plus 1 minus 1, that is n dx. Use the integration by parts. The first function is taken as x power n. First function into integral of second, that means x power n into minus e power minus x minus integral of derivative of the first n x power n minus 1 into integral of second, that is minus e power minus x. Take minus outside, so it becomes plus. So x power n into e power minus x integral is minus e power minus x. This integral part is over. Apply the limit 0 to infinity. Minus, and this minus, plus derivative of the first x power n derivative is n x power n minus 1. Integral of second is minus e power minus x. Therefore, this becomes plus e power minus x dx. And by the definition of gamma function, gamma n is integral 0 to infinity e power minus x x power n minus 1 dx. So this is gamma n. So n gamma n. And for this minus you take outside. E power minus x is 1 by e power x. X power n by e power x. Limit is from 0 to infinity. When you apply the upper limit infinity, infinity by infinity form, then use Dept.of rule. That is derivative of numerator is n x power n minus 1. Derivative of denominator is e power x only with minus sign. Okay, e power x derivative e power x. E power minus x is 1 by e power x, that is in the denominator. Again it is infinity by infinity form, and hence apply L'Hopital's rule n times totally. Numerator becomes constant, x power n derivative n times means n factorial. Denominator derivative n time means e power x only. A constant by infinity is 0. Upper limit value of this is 0, and lower limit of x is 0 means it is 0. Upper limit value is 0, lower limit value is 0, and hence this value is 0, and the resulting answer is n into gamma n. So gamma n plus 1 is n gamma n. Now this is for fractions. If n is integer, first you start with gamma 1. By the definition of gamma n function, gamma 1 is 0 to infinity e power minus x, x power 1 minus 1, x power 1 minus 1 is 0, x power 0 is 1. Therefore, gamma 1 is integral 0 to infinity e power minus x dx, and integral of e power minus x is minus e power minus x. Upper limit value is 0, lower limit value is minus 1, 0 minus minus 1 is 1. 1 can be written as 0 factorial. Gamma 2 is nothing but gamma 1 plus 1. Apply this formula. 1 plus 1, n is 1. 1 into gamma 1. And gamma 1 we just obtained, that is 0 factorial. 1 into 0 factorial is 1 factorial. Gamma 3 is gamma 2 plus 1. 2 gamma 2, n gamma n, n is 2. 2 into gamma 2, gamma 2 is 1 factorial, 2 into 1 factorial is 2 factorial. Gamma 4 is gamma 3 plus 1, 3 gamma 3, gamma 3 is 2 factorial, 3 into 2 factorial is 3 factorial. Similarly, gamma 5 is 4 factorial, gamma 6 is 5 factorial, gamma 10 is 9 factorial, and so on. In general, gamma n is n minus 1 factorial for positive integer n. So apply this formula only for integers, not for fractions. In fractions, gamma n plus 1 is n gamma n. Use this technique. Prove that gamma half is root pi. To prove this one, use the second formula of gamma function. That is, gamma n is 2 times of 0 to infinity e power minus x square x power 2n minus 1 dx. Now substitute n is half. N is half means 2 into half is 1, 1 minus 1 is 0, x power 0 is 1. Therefore, gamma half is 2 times of 0 to infinity e power minus x square dx. Or gamma half is 2 times of 0 to infinity e power minus y square dy. Either integrate with respect to x or y. So anything possible, both are same because limit is same, and hence gamma half can be expressed in terms of x or y. Now multiply these two. Gamma half into gamma half is gamma half whole square. 2 into 2 is 4. Integral 0 to infinity, 0 to infinity. E power minus x square into e power minus y square is e power minus x square plus y square dx dy. Change into polar form. So it's very simple. X vary from 0 to infinity, y vary from 0 to infinity is nothing but first quadrant, and hence theta varies from 0 to pi by 2, r varies from 0 to infinity. E power minus r square dx dy is r dr d theta. X square plus y square is r square, dx dy is r dr d theta. So either evaluate one by one or separate the variables and integrate. Now when you separate the variable, 4 into integral 0 to pi by 2 d theta into 0 to infinity e power minus r square r dr. Now multiply and dividing by minus 2. 4 by minus 2 is minus 2. Dividing by minus 2 and multiply by minus 2. R dr multiplied by minus 2. So if I take this minus 2 outside, it becomes 4 only. Same one. Why I multiplied this with minus 2? If minus r square is t, e power t, then minus 2r dr is dt. E power t dt integral is e power t, that means e power minus r square. So integral, the second integral is e power minus r square. Upper limit infinity means e power minus infinity is 0, lower limit 0 means e power 0 is 1. So 0 minus 1. So this integral value is minus 1. Here minus 2. Multiplication is 2. And integral of 1 with respect to theta is theta. Upper limit pi by 2. So 2 into pi by 2, that is pi. So gamma half whole square is pi. Minus 2. Here 1 integral, upper limit 1 integral is theta, upper limit is pi by 2, lower limit is 0, and this integral is e power minus r square. Upper limit is 0, lower limit is 1. 0 minus 1, that is minus 1. Minus minus plus 2 2 cancels, pi remains. Gamma half whole square is pi means gamma half is root pi. So that is the required answer. Next one, we will discuss some problems in beta gamma functions. In that, first one is evaluate beta 7, 6 using the relation between beta gamma functions. Beta mn is gamma m gamma n by gamma m plus n, and hence it is gamma 7 gamma 6 by gamma 13. And for the integral value, gamma n is n minus 1 factorial. Therefore, this is 6 factorial into 5 factorial by 12 factorial. Substitute this in calculator, you get 1 by 5544. 1 divided by 5544. One more example. Find the value of gamma 7 by 2. So it is not integer, so it is fraction. Therefore, use gamma n plus 1 is n gamma n formula. 7 by 2 can be written as 5 by 2 plus 1, and hence gamma 7 by 2 is gamma n plus 1, n is 5 by 2, n gamma n means 5 by 2 gamma 5 by 2. Again apply the same rule for gamma 5 by 2, 5 by 2 can be written as 3 by 2 plus 1, therefore 3 by 2 gamma 3 by 2, so 5 by 2 into 3 by 2 into gamma 3 by 2. Again 3 by 2 is 1 by 2 plus 1. Therefore, gamma 3 by 2 is half gamma half, but gamma half is root pi. Therefore, 5 by 2 into 3 by 2 into 1 by 2 into gamma half, that is root pi. 15 by 8 into root pi. Now see this. Suppose you want to find gamma 5 by 2. How to find gamma 5 by 2? Start with 1 less. That means 3 by 2, again 1 less, 1 by 2. Once you get 1 by 2 into root pi. Gamma 11 by 2. To find the value of gamma 11 by 2, start with 1 less means 11 by 2 minus 1 is 9 by 2. Again less 1. So 9 by 2 into 7 by 2 into 5 by 2 into 3 by 2 into 1 by 2 into root pi. And then simplify. That is how we can find the gamma value for the fractions with the denominator 2, 7 by 2, 5 by 2, 3 by 2 for that, because last gamma half is root pi, and hence you are able to write in one step the gamma value. Now question number 3, evaluate integral x vary from 0 to infinity e power minus 4x x power 2 dx using gamma functions. Now apply the formula integral 0 to infinity e power minus y power p dy, that is gamma p plus 1. To apply that formula, first you make 4x is y. Put 4x is y. Then x is y by 4. Dx is dy by 4. When x is infinity, y is also infinity. When x is 0, y is also 0. Therefore, limit remains same. 0 to infinity e power minus 4x x square dx becomes 0 to infinity e power minus y, x square means y square by 16, dx is 1 by 4 dy, so y square by 64 dy, y square dy by 64, 1 by 64 is taken outside. And by this formula, here n is nothing but 2, so gamma 2 plus 1 means gamma 3, gamma 3 by 64. Integral 0 to infinity e power minus y power p dy is gamma p plus 1. So y power 2 dy is gamma 2 plus 1. That is gamma 3 by 64. Gamma 3, since it is integer, gamma 3 is 2 factorial. Gamma n for the integral value, gamma n is n minus 1 factorial. Therefore, 2 factorial means 2. 2 by 64 is 1 by 32. Next example. Evaluate beta 5 by 2 comma 3 by 2. So gamma 5 by 2, gamma 3 by 2 by gamma 5 by 2 plus gamma 3 by 2. By the formula gamma mn is beta mn is gamma n by gamma m plus n. Gamma 5 by 2 is nothing but 3 by 2 into 1 by 2 into root pi. Gamma 3 by 2 is 1 by 2 root pi. And this is gamma 4. 5 by 2 plus 3 by 2 is 8 by 2, that is gamma 4, that is 3 factorial. 3 factorial is 6, cancel 1 3, 2 remains. 2 into 2 into 2 into 1 more 2, that is 16. Root pi into root pi is pi, therefore it is pi by 16. Next one, evaluate integral 0 to 1 x power 3 1 minus root x power 5 dx. Now make this is y. 1 minus y. So in the formula 1 minus y form, therefore y is root x or x is y square. So root x is y means x is y square. Dx is 2y dy. And limit when x is 1, root 1 is 1, y also 1. When x is 0, y is 0. So limit remains same and hence integral 0 to 1 x cube 1 minus root x whole power 5 dx is, see this becomes 1 minus y power 5, fine, x cube y square cube, that is y power 6, and dx 2y dy, take 2 outside, y power 6 into y is y power 7 dy. Then use the formula integral 0 to 1 y power p 1 minus y power q dy is beta p plus 1 comma q plus 1, beta 8 comma 6. So 2 times of beta 8 comma 6, that is 2 into gamma 8 gamma 6 by gamma 8 plus 6, that is 14. Again for the integral value gamma n is n minus 1 factorial, therefore 2 into 7 factorial into 5 factorial divided by 13 factorial. Substitute in calculator, so you will get the answer 1 by 5148. One more example, very important one because this problem covers all the formulas in beta gamma functions. Integral 0 to pi by 2 root sine theta d theta into integral 0 to pi by 2 1 by root sine theta d theta equal to pi. How to prove this? In the left hand side, first use the definition of the beta function, that is 0 to pi by 2 sine power p theta cos power q theta d theta is half beta p plus 1 by 2 comma q plus 1 by 2. Therefore, left hand side can be expressed as integral 0 to pi by 2 sine power half theta, no cos means cos power 0 theta d theta, into integral 0 to pi by 2 sine power minus half theta, 1 by root sine theta means sine power minus half theta cos power 0 theta d theta. Then by this formula integral 0 to pi by 2 sine power p cos power qx dx is half beta p plus 1 by 2 comma q plus 1 by 2. Here p is half. Half plus 1 is 3 by 2. By 2 is 3 by 4. Q is 0. 0 plus 1 is 1. 1 by 2. And hence half beta 3 by 4 comma 1 by 2. And this one half beta p is minus half. Minus half plus 1 is half. Half by 2 is 1 by 4. And 0 plus 1 by 2, that is 1 by 2. And beta mn is gamma m gamma n by gamma m plus n. So using this formula, that is 1 by 4 gamma 3 by 4 gamma 1 by 2 divided by gamma 3 by 4 plus 1 by 2. So that is gamma 5 by 4. And one more is Gamma 1 by 4, gamma 1 by 2 divided by gamma 1 by 4 plus 1 by 2 is 3 by 4. So this 1 by 2, 1 by 2 is 1 by 4, that is taken outside. Now, gamma 3 by 4 cancels. Gamma half into gamma half, root pi into root pi is pi. Remaining term is 1 by 4 gamma 1 by 4, that is numerator. Denominator gamma 5 by 4. And we know that gamma n plus 1 is n gamma n. So 1 by 4 gamma 1 by 4 is gamma 1 by 4 plus 1, that is gamma 5 by 4. So gamma 5 by 4 divided by gamma 5 by 4 cancels. So pi remains, therefore it is pi. That means we are going to use the definition of beta functions and relation between beta and gamma functions, and gamma half formula and gamma n plus 1 formula and this one. So all this we used here to establish the result. So that is equal to pi. So that is right hand side. One more example. Evaluate 0 to pi by 2 root tan theta d theta. Tan theta is sine by cos. Therefore, square root of sine theta by square root of cos theta is nothing but sine power half theta cos power minus half theta d theta. So by the previous formula, that is half beta p plus 1 by 2 q plus 1 by 2 means half beta half plus 1 by 2. So that is 3 by 4 minus half plus 1 by 2, that is 1 by 4. And by the gamma function, half gamma 3 by 4 gamma 1 by 4 by gamma 1. Gamma 1 is 1. Therefore, it is gamma 3 by 4 gamma 1 by 4 divided by 2. That is the required answer. You can stop there only. Or if you remember the formula, gamma n into gamma 1 minus n is pi by sine n pi. Just rearrange this. Gamma 1 by 4 into gamma 3 by 4 is, here n is 1 by 4. Sine pi by 4 is 1 by root 2. Pi by 1 by root 2 is root 2 pi. So you can substitute this value, that is root 2 pi by 2. So that is pi by root 2. So this result, so it comes in Fourier series, therefore no need to worry. If you remember this formula, then only apply, otherwise stop here only. Gamma 3 by 4 into gamma 1 by 4 divided by 2, that is required answer for this. Or you can write pi by root 2 if you know this formula. Okay. Now same type, one more question. If it is root cot theta, cot means cos by sine, therefore here minus sine, sine power minus half theta, cos power plus half theta. So just interchange 1 by 4, 3 by 4. Answer is same because gamma 1 by 4, gamma 3 by 4 is root 2 pi. Therefore answer is pi by root 2. For root cot theta also it is pi by root 2. Next question. Evaluate integral 0 to 1 x power 5 1 minus x cube whole power 10 dx. Make this x cube is y. That is very simple technique. X cube is y means x is y power 1 by 3. If x is y power 1 by 3, dx is 1 by 3 into y power 1 by 3 minus 1 dy. 1 by 3 minus 1 is minus 2 by 3. We substitute these values. Limit remains same because x is 1 means 1 cube is 1. X is 0 means 0 cube is 0. Therefore 0 to 1 only. So this becomes x power 5 y power 5 by 3. X power 5 is y power 5 by 3. Dx 1 by 3 y power minus 2 by 3. Y power 5 by 3 into y power minus 2 by 3 to y power 3 by 3. That is y. Take this 1 by 3 outside. Y into 1 minus y power 10 dy. By the formula, it is beta p plus 1 comma q plus 1. P is 1 here, 1 plus 1 is 2, q is 10, 10 plus 1 is 11. So 1 by 3 into beta 2 comma 11. That is 1 by 3 into gamma 2 gamma 11 by gamma 13, sum of these two. Gamma 2 is 1 factorial, gamma 11 is 10 factorial, gamma 13 is 12 factorial. Substitute this in calculator, you get 1 by 396. Now So we use this formula, integral 0 to 1 y power m 1 minus y power n dy is beta m plus n comma n plus 1. The last problem, find the value of gamma minus 5 by 2. Actually, for the negative values, it's not good. We are not going to use the formula. But in some problems, in some textbook, they explain this. Therefore, I am going to explain how to evaluate gamma minus 5 by 2. We know that gamma n plus 1 is n gamma n. Therefore, gamma n can be written as gamma n plus 1 by n. If n is negative, use this technique. Gamma n is gamma n plus 1 by n. And hence, gamma minus 5 by 2 is gamma minus 5 by 2 plus 1 by minus 5 by 2. N is minus 5 by 2. N plus 1 is minus 3 by 2. Minus 5 by 2 plus 1 is minus 3 by 2. Again, apply the same rule for this. Gamma minus 3 by 2 is gamma minus 3 by 2 is gamma minus 3 by 2 plus 1 by minus 3 by 2. So, minus 3 by 2 plus 1 becomes minus 1 by 2. So, gamma minus 1 by 2 divided by minus 5 by 2 into minus 3 by 2. Again, apply the same rule. Gamma minus 2 by 2 plus 1 by minus 2 by 1 by 2. Minus 1 by 2 plus 1 by minus 1 by 2. And hence it is gamma 1 by 2, because minus 1 by 2 plus 1 becomes 1 by 2 divided by minus 1 by 2. So, minus 5 by 2 into minus 3 by 2 into minus 1 by 2 is in the denominator. Numerator gamma half, that is root pi. 2 into 2 into 2, 8. 8 goes to numerator. 5 into 3, 15. Minus minus minus, that is minus. Therefore, minus 8 by 15 root pi. That is how we can evaluate the gamma function for negative number also. So, if the n is negative, use this technique. Gamma n is gamma n plus 1 by n, and repeat this continuously until this number becomes positive. First, see this, when you add 1, this is minus 3 by 2, again add 1, minus 1 by 2, again add 1, it is 1 by 2. Every time when you add, that number comes in the denominator. See here, minus 5 by 2 is here, minus 3 by 2, again minus 1 by 2 comes here, and this becomes half. Gamma half is root pi, and this denominator is 8, it goes to the numerator. Minus minus minus, that is minus 3 into 5 is 15. Okay. I hope you got the idea of beta gamma functions. Thank you for watching. So, third module, double integral or integral calculus of the 18 MAT 11 completes. Thank you.